We finally arrived at a video in which we're going to be evaluating trig functions mentally, very quickly as a matter of fact, but using reference angles as opposed to the original angles that were given. So for instance, the build-up, this is all going to be build up here for essentially I want to be able to find, say, the sine of 5 pi thirds in my head, like right now, know the answer, and not have to think that hard about it, but just by using a reference angle as opposed to this original 5 pi thirds reference angle, 5 pi thirds angle rotation. So the reason why we're going to use reference angles instead is, let's deviate up here, we say, let's talk about how reference angles are related, or at least how reference angles, the trig function value of a reference angle is related to the trig function value of its original angle, theta. Okay, so let's say given some point xy, and xy is on the terminal side of some angle, and I've actually sketched this here, so we have some angle theta, okay, and this is our angle theta here. We have a point xy on its terminal side. So for instance, we already know that this dimension here, this opposite dimension, is y, and then adjacent dimension down here is x, and we know that this is our hypotenuse, as a matter of fact. What I want to know is this: how would the sine, or say the tangent of this angle theta, be related to the sine or the tangent of its reference angle instead, okay? And what I want us to recognize is this. Well, we know that the sine of this angle here, theta, would be the y value of our point, or this r value right here, just by definition of the value of sine. And we say the value of tangent in this instance would be y over x, of course, opposite over adjacent, or you say y over x, just by the definition. That would be the values of these two trig functions of the original angle theta. My question is, what if we had done this with the reference angle instead? And you'll notice here that the reference angle, of course, is the acute angle formed by the terminal side of this angle on the x-axis, okay? So again, dropping down this, you can see how I've dropped down an altitude here and formed this right triangle. But if we were to do, say, the sine of theta prime, sine of theta prime would be opposite over hypotenuse, so I still get y over r. And if I were to do, say, the tangent of theta prime, I would get y over x. I would still get y over x. It's just that in this instance, we say that the sine of theta prime is equal to the absolute value of y over r, and that the tangent of theta prime is equal to the absolute value of y over the absolute value of x. Now, why am I using absolute values? The idea here is this. Given this angle theta, you notice that this terminated in the second quadrant. So our original point here, xy, had a negative x value, and it had a positive y value. If we had sketched just the reference angle on its own, forget theta, just go sketch theta prime, which is this acute angle right here, it would have been in the first quadrant, because recall that all reference angles are positive and acute. We would have had some point xy over here that would have had the same numbers. The only difference would have been that both of these numbers would have been positive. You'll notice that it makes the same exact triangle, except for the only difference are the signs and its values. And I don't mean S-I-N-E, I mean S-I-G-N. Okay? So essentially, the profound implication here is this. We say the profound implication is then that the trig functions of an angle, we say an angle theta, and its reference angle, theta prime, the most they can be different by, the only thing that could make them different, the sine of theta and the sine of theta prime, or the tangent of theta and the tangent of theta prime, you're going to have the same exact numbers because of congruency here. It's just that they can differ at most in SIGN. So the profound fact here is this. If you want to go find the sine, for example, the sine of an angle, it would have to be the same number of as its reference angle. The only difference might be that it might be positive or it might be negative. So what we're going to do in this video is I'm just going to outline a method for finding the trig function of any angle that goes back down to these down here. But we'll just use the reference angle instead, because we know by looking at this image up here, this sketch, that you got to have the same numbers anyways. So why not just use the reference angle, because we know reference angles very well. So to find the value of a trig function of any angle theta, here's what we're going to do. It says determine the function value for the associated reference angle first. That is, if somebody asks me to go find, say for instance, the sine of 120 degrees. And you know what, I'll carry this one out here, but we'd say 120 degrees would be right here, be 30 degrees past 90. So we'd say, what is the sine of 120 degrees? Okay. Since if I were to drop this down here, I get this triangle right here, I could say its reference angle is 60 degrees. 60 degrees. What I'm going to tell you is this. Whatever the sine of 120 is, what we're saying here on the step one is this. Let's just go do the sine of its reference angle instead. Now, why would I want to go do the sine of its reference angle instead? Now, let me sketch you a 60. We'll talk about what this looks like here. You know, some point xy on the terminal side. I want us to compare these two triangles, and I hope you see this. These two triangles have the same dimensions. Whatever point is over here on this side, this point xy, it's going to be the same magnitude, or the same size as the point of these values over here, xy. So what we'll do is we'll just go find the sine of 60 instead. And then step 2 says this: depending upon the quadrant in which theta lies, we will affix or set the appropriate SIGN sign to the function value. So what we're saying here is this: the sine of 120 degrees has to be the same thing as the sine of its reference angle. It's just that we need to put out front either a plus or a minus depending upon, you know, what its value should be. And here's where the kicker comes in. We say that we already know this little mnemonic here. We say all students take calculus. Since our original angle theta terminated in the second quadrant and we are finding the value of sine in the second quadrant, we know that its y value is going to be positive, or at least that the sine value will be positive. So here's basically what we were able to just determine. If I wanted to go find the sine of 120 degrees, we should just go do the sine of its reference angle anyways, and in this case we'll call it positive because in the second quadrant sine is positive. And so in this case we get the sine of 120 is the same as the sine of 60, which is, by the way, root 3 over 2. Now, why? Why do I know this is root 3 over 2 very quickly? Now I will tell you this, I can't help you here. You're going to have to know this, but I mentioned this up here. We say use reference angles and special right triangles that we're familiar with to generate the following table of standard values. Basically, I've already generated this table for you, but I want you to memorize all of these values here. And you'll notice that I'm including values like 30, 45, 60, but I also have 0, 90, 180, and 270. All of the values in this table right here can also actually be found using your unit circle. And another thing I tell people is this: the only part of the unit circle you need to memorize is the first quadrant. Okay, recall that the unit circle has a radius of 1. So if that's the case, then this would be the point 1, 0 on the xy coordinate plane, and this would be the point 0, 1. But if we were to sketch in our pi 6th, pi 4th, and pi 3rd radian measurements, and if you're talking about, of course, if you're talking about degrees, we say are 30, 45, and 60. These points on the outside of the unit circle, recall, what they do is they tell us the cosine of the angle and the sine of that angle, respectively. Okay, so we could use those to go evaluate trig functions. The thing that these all have in common, just like in this table right here, 30, 45, and 60, is that they're all over 2. And this is kind of how I remembered it when I was going through trig the first time. But it says going down on the left here we say 1, 2, 3, and going back up on the right it's 1, 2, 3. But basically this is 1 over 2, root 2 over 2, root 3 over 2. And this would be 1 over 2, root 2 over 2, root 3 over 2. Okay. So what I want to go to show here is essentially this. You could evaluate all these trig functions down here just using the reference angles instead, and then we'll either call it positive and negative to make it appropriate to the quadrant in which our angle theta terminated in the first place. So sine of 5 pi thirds. How could I do this very quickly with reference angles? Well, first thing I'm going to tell you is this. Go ahead and write this. It's going to be the same thing as plus or minus the sine of its reference angle. I mean, it's got to be the same thing as the sine of its reference angle since it would form the same triangle. And I say, well, what does the reference angle do at 5 pi thirds angle here? So we say if theta is 5 pi thirds, what is our theta prime? And we can visualize this here. 5 pi thirds, that would be 1 pi third, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds. So here's our 5 pi third radian rotation here. We say, what would the reference angle be? It'd just be this extra pi third. So what I can tell you is this. Instead of having to do the sine of 5 pi thirds in my head, we could just say it's the same as sine of pi thirds, which, by the way, is 60 degrees. And if you want to go look at your unit circle here, we say that the sine of that value is root 3 over 2. So essentially, we get this. It's either going to be plus or minus root 3 over 2. It's got to be a root 3 over 2. And the question now becomes this. Which one of these is it? Is it the plus or is it the minus? And the way we determine this is essentially this. Our original angle, this 5 pi thirds, which is, by the way, down here, terminated in the 4th quadrant. So if that's the case, there's our theta. We say all students take calculus. Cosine is the only thing that's positive down here. So if I'm finding sine, then I'm going to just keep the negative. So in other words, the sine of 5 pi thirds has to be negative root 3 over 2. And that's all there is to it. Seriously, we're just going to use the reference angles. Okay. How about these last two here? We say, well, how can I easily find the cosine of negative 60 degrees? Well, instead we'll do plus or minus. It's one of those two. Cosine of its reference angle. We say, what's the reference angle on a negative 60? Well, if you rotated negative 60, you've gone counterclockwise, or sorry, clockwise, negative 60 degrees here. Its reference angle would actually be 60 degrees. So we know that we're going to get the same thing as the cosine of 60 here. And by the way, the cosine of 60, I should have this one memorized, but if I don't, I can look up here. We say, here's my 60-degree angle. There's the cosine value. It's a half. So we're going to get this. I'm going to get a half is my cosine of 60. And because we were in the fourth quadrant here, we say all students take calculus. Cosine is positive, so we'll go with the positive one. So we say the cosine of negative 60 degrees is literally a half. Now, we could have told you this, by the way, because of the fact that cosine is an even function. We could have said that the cosine of negative 60 is the same thing as the cosine of positive 60 anyways. Okay. And then last but not least, tangent of 11 pi 6. Now, that's a little bit different. We're doing a tangent here. But what I know is this. It has to be equal to plus or minus the same thing as its reference angle, whatever the reference angle of 11 pi 6 is. And think about this. 11 pi 6, if you were to sketch this out, this would be 12 pi 6, one full rotation, that's 2 pi, so we would say 12 pi 6 would be there, so 11 pi 6 is right here, then its reference angle is this leftover pi 6. So whatever the tangent of 11 pi 6 is, it's the same stinking thing as the tangent of pi 6, just that what is the tangent at pi 6? And pi 6, which is a 30, we say the tangent of a 30 is just root 3 over 3. And I can look at my table up here, I can go back up here and reference this, but it's good to just know that the tangent of 30 degrees is root 3 over 3. So we get this, we get root 3 over 3, and then the last question is just this, should I make it positive or negative? Well, again, all students take calculus. The only thing positive in the fourth quadrant is cosine, so this tangent value, it's just going to be negative, okay? So from now on out, if anybody ever asks you to find the sine, cosine, or tangent, or any trig function of an angle, just do the reference angle instead, and then call it plus or minus appropriately, depending upon where it terminated. Cheers.